Hey YouTube, so welcome to my new little science video series. I'm actually very excited about these videos, as you can see by the lab coat and everything. So yeah, today's video is going to be on how to science for noobs. So as I'm sure a lot of the science people in the audience will know this, there's quite a bit more to science than meets the eye. So for example, one does not simply read scientific literature and understand it perfectly, for one, much less use it in an argument for another. So if you are interested in reading science for an argument or for just interest's sake even, then this video is aimed at you. I know one of the most annoying things that grates my tits is seeing people on social media who come in with such grand sweeping statements about things that they don't actually know what they're talking about. So yeah, with this video I'm trying to encourage everyone to please, you can take whatever argument you want, but please make sure you know what the fuck you're talking about, because if you don't, you're gonna look like an idiot and we're gonna laugh at you. So yeah, first thing that you need to keep in mind when you're reading a scientific article is that it's gonna be complicated. So science is complicated, guys. There's no ways around that. If there's things you don't understand, you're just going to have to look it up. So when people use the argument, don't use your jargon to confuse me, yada, yada, yada. Trust me, we've got better ways to spend our time. We are not trying to confuse you with fancy jargon. We're really not. There's a quote by Einstein: make it as simple as possible, but no simpler. So we can only simplify things as so far. If we simplify it any further, we'd actually be saying things that are wrong. So at the end of the day, jargon is a necessary evil as far as all of this is concerned. But don't worry, if you don't understand the words, Google them. And I'm not even joking, Google them, because then, boom, problem solved. Second thing, which is arguably also just as important when you're reading scientific literature, is bias. So bias comes in many different shapes and forms, and it is the biggest enemy of sort of sciencing. So bias is when somebody else's opinion, okay, this is the easiest example I can think of off the top of my head now. One of the easiest examples of bias is when you're reading a scientific journal article, avoid the abstract at the beginning of the journal article. The abstract is a brief summary of what the journal is doing and everything that the journal covers. But the problem with reading the abstract first is you read what that author interpreted out of his results. And his interpretation might be wrong. His results might be correct, but his interpretation can be wrong. And if you read his interpretation, you're instantly only going to think about what he thought happened. So that is bias. And it comes in many different shapes and forms. So another one, for example, is if you are using this in the case of an argument or an assignment or an essay or whatever, then if you go looking for a journal article that answers a specific question, then you're also being biased. Because that is like looking at people and saying, I want to prove that male blondes are evil. So you go out into the world and you wait for a male blonde to do something wrong, and then as soon as they do something wrong, you're like, ha! See, they're evil, they must die. So, bias, avoid it. So yeah, then when you're actually reading the journal, and just before I get into that actually, you should be reading journals and not other scientific sources. So if you really are trying to make a scientific argument or touch base with the scientific community, you should be reading journal articles. Any sort of other literature, not really scientific. So the key thing about scientific journals is that they are what we call peer-reviewed, meaning when you do your research and you come up with your write-up and whatever, you send it into the journal company and they will screen your experiment and they will look through it and say, okay, there's a problem here, your logic here does not make sense, and this result, your maths does not work out. And then they will send it back to you, and then you've got to fix all the problems and that sort of thing. And obviously, in order to be able to tell you, listen, your maths is wrong here, your logic is wrong here, they send it to other people who are also qualified and will know, okay, listen, this oak is wrong here, or, oh, shit, okay, wow, this oak is onto some hectic stuff, you know? So that is why you should be sticking to peer-reviewed. If you find an article on Wikipedia, avoid it like the plague. Although Wikipedia is quite often correct, the problem with Wikipedia is it is not peer-reviewed, and pretty much anybody can put anything on a wiki and sell it as gospel. So stick to journal articles. It's just easier that way. Textbooks as well, they are also peer-reviewed and accepted to a certain degree. And then when it comes down to journals, you're going to want to stick to respected, famous journal titles. So for example, two journals just off the top of my head, Nature and Genetics. Those are pretty big journal names and they're well respected. So usually well-respected journals have good, solid science in them. Whereas if it's some funny journal from Mexico or Brazil that you've never heard of, then chances are their science might not be so kosher. They might not have peer-reviewed it by actual people who are qualified to be doing the peer review, people who don't know enough to peer review. So also watch out for that. Now, back to when you're reading the journal article, the first thing that you're going to want to do is, like I said earlier, skip the abstract. You don't want bias because that can fuck you up. Then go to the intro and read a bit. Every journal article will introduce their topic. Okay, well, this is a problem in the world, you know, and so they will then introduce what they are focusing on. So your job for the introduction is, cool, figure out what the hell are you doing and why. What is their big question? What problem are they solving? Then, after that, once you've got that down, and like, I mean, really, you know exactly, okay, this is a problem in here and here and here, and these areas all over the country, yada, yada. Once you figured all of that out, go to their methods. And then in their methods, this is like the crucial bit though. So in their methods, look at what they are doing, and then you need to figure out, you need to understand how what they are doing answers their question. So for example, if I say, I'm testing for this and protein such and such in yeast cells, then you need to be able to say, okay, so they were testing for that protein, and the reason they're testing for that protein is because it means this, and this will answer your question. That will make your question yes or no, or whatever your answer is. Then, next up, you're going to go to the results. Then, in the results, provided you understand what the problem they are trying to solve and the method, how they are going about trying to solve their question, then the results should be a cakewalk, because you should already know what the results mean, because you understand how they were obtained, and you should already know what they mean in terms of the big question. So conclusion, you should already know from results. Then only you get to the conclusion, and then you can see what that author, how they interpreted it. And it is a thing that sometimes their observations might not be 100% accurate, or maybe you do not agree with it. But now, in the case of non-scientists, if you do not agree with their opinion, that's fine. Like, science is not a by-the-book thing. It's all about variability and opinion. That is actually, a lot of people don't realize this, but that's what the scientific community runs on. Is, okay, well, I found these results, but more importantly, this is what I think they mean, because this is my theory. Darwin, look at Darwin. So you are allowed to have a different opinion to any that they come up with in a journal, which is why I encourage you to skip the abstract first, because it helps you formulate your own opinion. If they are they have read their results accurately and you have read the results accurately, chances are you're going to come to the same opinion, which is good, but it's not like a huge deal if you don't. It is a case. And then, yeah, basically with this video, I really just want to encourage everyone, please just think for yourself. I'm not trying to sway anybody's opinion about any arguments or whatever. But please do not bury your head in your fucking ass and then go and talk about things that you do not know about. Talk about them. Because that's the whole point of this, is to spread knowledge around the world. That's what science is about, is to teach. But you can take a horse to water, you can't make it drink. So this is as much about reading on your guys' as everybody else's part as it is on science's part. So yeah, I hope you guys enjoyed this video. I hope it helped. And yeah, I hope you guys go and get some hectic scientific reading done. So yeah, like and subscribe, and if you guys have any questions or requests or whatever, then shoot me a message in the comments below. Cheers!